today's our topic is reaction of metals with acids. Now, whenever metal react with acid, it forms salt plus hydrogen gas is released. Means whenever a reaction is occurring between metal and acid, then there will be formation of a kind of salt which we will call the metal salt, as it is easy. How is it forming? From metal only, so what we'll call it a metal salt, and hydrogen gas is releasing in that case. If we talk about some examples, then you can see I am taking magnesium. When magnesium reacts with hydrochloric acid, that is HCl, then there is a formation of MgCl2, magnesium chloride. And again here the hydrogen gas is releasing. If we talk about aluminium, so aluminium react with HCl, then there is a formation of AlCl3, plus here also the hydrogen gas is released. So if a reaction is occurring between metal and acid, then there will be release of hydrogen gas. Now as you can see here, I had written 2, 6, 2, 3, etc. These things are written for balancing a chemical equation. Means this side is known as left hand side of a reaction, this side is known as right hand side of a reaction. So both sides the element should be get balanced. Here you can see 2 aluminium, here also 2 aluminium, here 6 hydrogen, here 3 2s are 6 hydrogen atoms, here 6 chlorine atoms, here 3 2s are 6. So this is just for balancing a chemical reaction. Now if we talk about the order of reactivity of metals with acids, then this can be understood by the reactivity series. In the reactivity series, you can see potassium, sodium, calcium, they all are arranged in the reactivity order. The topmost are the highly reactive substance with acids, and the up to here these are the least reactive. If we talk about copper, silver and gold, then there is no reaction between these metals with the acids. They do not react with the acids. Now there is a trick to learn this reactivity series which I am going to tell you, so you can also easily remember this by this tricks. So what is the trick? Let's see. For potassium we'll use please P for potassium. Please stop calling me. Please stop calling me a zebra. Please stop calling me a zebra in the library. Call something good. So easily you can learn. Please. So P for please, P for potassium. Please stop, S for stop, S for sodium. Stop calling me, that is magnesium. Zebra, that is aluminium. Zebra, that is zinc. In the library, call something good. So this is how you can easily learn the reactivity series. This is the trick to learn the reactivity series. Next topic is reaction of metals with bases. So first we'll talk about what do you mean by a base. It was in your class 7th also that base used to have a beater test, and they turns red litmus paper into blue. And opposite of base is what? That is acid. It turns blue litmus paper into red. Now whenever metal react with base, they also form salt and hydrogen gas is released. Here also the hydrogen gas is released. If we talk about some examples, then sodium hydroxide we are taking and reacting it with the zinc. Zinc is reacting with the sodium hydroxide, that is a base. When they react, there is a formation of Na2ZnO2, that is sodium zincate. Na stands for sodium, Zn stands for zinc, so that is sodium zincate. Plus here also the hydrogen gas is releasing. If we talk about the reaction of sodium hydroxide with aluminium, then we'll observe that there is a formation of sodium aluminate. Here the sodium zincate was formed, here sodium aluminate is forming. Na stands for sodium, Al stands for aluminium. So there is a formation of NaAlO2 plus 2H2. Again here 2, 2, 2, these things are coming for balancing the chemical equation. Now regarding this chemical equation, we are having one activity also in our book, that is activity 4.7. In this, what we are going to see, that first we'll prepare a fresh solution of sodium hydroxide. So for preparing a sodium hydroxide solution, what we'll do, we'll take sodium hydroxide and add it to 5 milliliter of water. So we'll get a fresh solution of sodium hydroxide. Now in this solution, what we are going to do, we'll drop a piece of aluminium into it. We will simply take aluminium foil which we used to have at our home also. So we'll take it and dissolve it in the sodium hydroxide solution. So after some times, we'll see that there will be formation of sodium aluminate. There will be formation of what? Sodium aluminate. Now for testing hydrogen gas, there is a basic test that if bringing a burning matchstick near the mouth of the test tube, we will take a test tube and bring a burning matchstick. We will take a matchstick and burn it and keep it nearby the test tube. So what we'll observe, there will be a pop sound. There will be a production of pop sound which indicates that hydrogen gas is releasing. So this is a test to check that hydrogen gas is releasing or not. Now our next topic is displacement reaction. It is a very important type of chemical reaction. If we talk about the definition of this displacement reaction, then we will say that the type of reactions in which highly reactive substance or metal takes place of less reactive metal, then such kind of reactions are known as displacement reaction. अब here I am using two terms, that is highly reactive and less reactive. So in the previous section we had already discussed about the reactivity series, in which the metals which were coming on the top side were highly reactive metals and which were coming at the bottom were less reactive metal. From that only we are taking one example, that is, we know that zinc is more reactive than copper because zinc used to come upside in the series as compared to the copper. So we are taking zinc and reacting it with copper sulfate solution, CuSO4. SO4 stands for sulfate. So we are taking copper sulfate solution. When zinc react with this, so it used to take place of Cu. It is displacing Cu, that is copper. From here you can see zinc is displacing Cu and forming ZnSO4 and copper. So from this we can say that it is a displacement reaction because highly reactive substance is taking place of less reactive substance. During this reaction, what is actually happening, that CuSO4 which used to have a blue color, when in this solution we used to add Zn, that is zinc, then the solution becomes colorless. More examples we are going to discuss in our activity 4.8. In this activity, we are taking 5 beakers of 100 ml each and naming them A, B, C, D, E. Like this, here I am taking 5 beakers, that is first, second, third, fourth and fifth. A, B, C, D and E. Now in first beaker I am taking copper sulfate solution, that is CuSO4. In second beaker also I am taking copper sulfate solution. In third beaker I am taking zinc sulfate solution, ZnSO4. In fourth beaker I am taking FeSO4. And the last beaker I am adding ZnSO4. So here now we are having 5 different solutions of metals. Now in this we are going to add different types of metals and we will check that reaction is taking place or not. So in the first beaker I am adding zinc. In the second beaker I am adding iron, that is Fe. In the third beaker I am adding copper, that is Cu. the fourth beaker I am adding zinc, and the last beaker I am adding iron as per the activity. So in first one, when zinc was reacting with copper, so now we'll check that the reaction is taking place or not, because here we have to firstly check that only highly reactive substance will displace the less reactive substance. So now here there will be requirement of our activity series which we had already learned. So if we compare zinc and copper, so which one is coming upside? Zinc. And which one is coming at the bottom? Copper. So that means what? Zinc is more reactive than copper. So here the reaction will be taking place and there will be formation of ZnSO4. There will be formation of ZnSO4. If we talk about similarly in the next reaction, so what we are having, if we talk about iron and copper difference, you can see, so iron is coming upside and copper is here. So again iron is more reactive than copper. So reaction will be taking place and there will be formation of FeSO4. In third case, if we will compare, so here copper is at bottom and zinc is at upside. So zinc is more reactive than copper. So there will be no reaction or no change because copper is less reactive. So as per the rules, there will be no reaction. If we talk about next, that is zinc and iron one case. So zinc is coming just upside of that iron. So there will be reaction taking place. That is ZnSO4. If we talk about the last beaker, that iron and zinc, so here there will be no reaction. So this is how, with the help of activity series, we can check that if a substance is more reactive or less reactive and the reaction will proceed or not.